Hey Algebra 2, today we're going to learn about properties of logarithms. So in some forms, your logarithms will be in what we call expanded form. Expanded form means that you will be able to see addition or subtraction or multiplication happening. Before we can solve a logarithmic equation, they have to be fully condensed. So that's what we're going to learn today. How do we condense something? When you have an addition sign between it, to condense it, you're going to take the m and the n part right there, and you are going to multiply it. So for example, if you see log base 4 of 3 plus log base 4 of x, I have the same base. Addition means you multiply these, and that becomes log base 4 of 3x. If you see subtraction gets condensed with division. So the one after the subtraction sign always goes to the denominator. Subtraction uses division. So if you see log base 2 of x minus log base 2 of 4, I'm going to condense that by writing it as log base 2 of x divided by 4. The other thing that I would like to point out is that in the condensed form, you should only see the log written one time. Here in expanded, the log is twice. In condensed, it's only once. If you have a number or a letter in front of the log, this is multiplication. Multiplication, you're going to take that number out in front and it moves to the exponent. It moves to the back and it becomes an exponent. So if you see something like 5 log base 3 of 2x plus 1, this 5 multiplication, we're going to move it to the back of your 2x plus 1 parentheses. We're going to have log base 3 of 2x plus 1 to the 5th power. So when you condense, you have to figure out what should I do first. So if you see any multiplication, you should always do that first. And that means you're going to move to the exponent. If you see addition, do that next. You're going to multiply to condense. And if you see subtraction, you're going to divide to condense. All right, so the first one, I have log base 5 of 4 plus log base 5 of 3. I see addition right there. So when I see addition, I condense using multiplication. So it's that 4 and that 3 part that are going to get multiplied. So I have log base 5 of 4 times 3. That gives me log base 5 of 12. Number 2 is also addition. When you have addition, you condense by multiplying. So I have log base 6 of x minus 3 times x. I am going to go ahead and distribute this. So I have log base 6. X times x is x squared. Negative 3 times x is negative 3x. Let's keep this in parentheses so that we see that it's all together as, like, I think this is called the argument. few more. Number 3, I have subtraction. So when you have subtraction, you're going to condense by division. So I have log base 5, the x goes in the numerator, and the x plus 2 goes in the denominator. Now it is fully condensed. Number 4, you have both addition and subtraction going on. So where you see the addition, that means you're going to multiply, and then here, when you see the subtraction, that is going to divide. So here's what it looks like when you are able to do it all at once. The 5 and the x multiply become 5x. That minus 10 right there means your 10 is the denominator of the fraction. I have 5x over 10. I would probably go ahead and reduce that. I have log base 2 of 1x over 2. 5 and 6. So on 5, I see a number out in front. So this is multiplication. We're going to take that and we're going to move it to the exponent of the x. So that reads log base 2 of x to the 5th minus. We're going to take that 2 and we're going to move it to the exponent. Log base 2 of y to the 2nd. Now, I still have subtraction, so that means that I need to condense one more time. Subtraction condenses by division. So I have log base 2 of x to the 5th over y to the 2nd. Last one. Let's see. I have multiplication right there, so you're going to move. And I have multiplication, and so the 4 moves to the y. So I have log of 5 plus log of x to the 3rd minus log of y to the 4th. Now it looks just like number 4. I have addition, so I'm going to condense by multiplying those two. I have subtraction. I'm going to condense by dividing or moving that to the denominator. So I have log 5 times x to the 3rd is 5x to the 3rd divided by y to the 4th. We've done some change of base, and we're going to do it one more time. The change of base formula says if you have log base b of a, that gets me log a divided by log b. So the purpose of the change of base formula is so that we can get it out of something like a base 12 and get it into a base 10, because that's what our calculator can handle. So this 5/3, that is the a, and then that base 12, that's going to be your b. So I would rewrite this as log 5/3 divided by log 12. So you need to enter that in your calculator. All right, so here's my log button. I have a fraction, so I go 5 divided by 3. You have to close the parentheses. And then divided by log 12 equals, so I have this decimal. And I want most things as a fraction, so I'm going to hit the second and that to get the F to D. And, oh, I still get that decimal. Okay, let's see. We should probably round this to about 4 digits. So 1, 2, 3, 4. That gives me 0.205. And then that last one, the 7, rounds that up to a 6. 0.2056 for a good final answer there. The next one, so there's my A, there's my B. So I have log 75 divided by log 25. log 75 divided by log 25, 1.3413. On the next one, I have log of negative 3 divided by log of 5. Log negative 3 divided by log 5. And I get a domain error. Okay, so anytime you get a domain error, that is because this is no solution. And I'm off screen. There we go. Domain error means that you have no solution. It is because, right there, you were trying to take the log of a negative number. You can't take the log of a negative number. You get no solution. And then on the last one, I have log 20 divided by log 1/4. Let's see what the calculator says. Clear. Log 20, close parentheses, divided by log of 1 divided by 4 equals negative 2.160964. There's 1, 2, 3, 4 digits. That 6 rounds that 9 up to a 10, which is going to round that one up. Negative 2.1610. That looks pretty good to me. All right, we are done. Thank you.